How's it, grade 11s? Today we're going on to equations involving E and ln. Okay, so it's this chapter here, chapter 11, equations involving E and ln. Just going to go through these examples with you and then the homework. All right, so the question says solve for x correct to 2 decimal places. So question 1 is e to the x equals 6. Okay guys, so remember what we do here is I'm going to swap between exponential and log. Well, in this case, ln, okay, but it's the same thing. So remember, if we've got something like this, a to the y is equal to x, that means that y is equal to log x base a. And remember, we can swap between these two, okay? So that's what I'm going to do over here. So just by doing this, so the y goes to the front, so the x will go to the front. Equals. Now, we're not going to put a log, we're going to put a ln because it's e there, so ln. And the x comes down here, which is this thing, 6. Now, I don't have to put the e there because remember ln is, the base is e. Okay, so once we're at that stage, it's telling us to round off our answers to 2 decimal places. All you have to do on your calculator, you're going to go ln 6, and then we're going to round that off to 2 decimal places. So it's 1.79. Pretty easy. All right, so if we look at example 2, e to the 2x minus 6 e to the x plus 8 equals 0. Now, there's 2 ways that we can do this type of problem. What I want you guys to notice here is we have this e to the x and we have this e to the 2x. The one is double the other one. Now, as soon as you get something like that, we can use the k method, or you can go straight into factorizing it if you feel comfortable with that. So if I show you with the k method, so we let k be equal to the smaller of the 2. All right, so the smaller one out of these 2 would be e to the x. That means that k squared would be equal to, now all I have to do is square this, and we get e to the 2x, which so happens to be this one. All right, so this we can now change to e to the 2x becomes k squared minus 6 e to the x becomes k plus 8 equals to 0. What I have to do now is just factorize. And then I can solve for k. Okay, but you remember what the question was? The question was to solve for x, and we solve for k. So now I must back substitute. So we know what k is equal to. It's e to the x. So here we get e to the x is equal to 4. E to the x is equal to 2. Okay. I'm at this stage now where I'm going to reverse it to put it into ln form or log form. So we get x is equal to ln 4. X is equal to ln 2. All right, so what we're going to do, just on the calculator, ln 4, round that off to 2 decimals, so we get x is equal to 1,39, and then over here we've got ln 2. And we get x is equal to 0,69, okay? The other way that we could have done it, if you can see that this is a trinomial, we can factorize this trinomial. And we will get e to the x, because e to the x times e to the x will give us e to the 2x. And inside our brackets, minus 4, minus 2. So you'll get e to the x is equal to 4, or e to the x is equal to 2, which is coming back down to here. So if you can't see that it's a trinomial and factorize it immediately like this, you can use the k method. You will get the same answers. Okay. Going on to example 3. Well, we've got 2e to the x equals 1 plus e to the minus x. Okay, so what I'm going to do here is I don't like the negative exponents, so this will become 2e to the x equals 1 plus 1 over e to the x. Okay, now in order to get rid of that fraction, I'm going to multiply through by e to the x. So if I multiply that by e to the x, I get 2e to the 2x equals e to the x plus 1. So basically what I did is I multiplied through by an LCD of e to the x. Okay, what I can do now is take everything to the one side, and we get 2e to the 2x minus e to the x minus 1 equals to 0. Now, this is very similar to the previous example where we've got the one e to the x is double the other e to the x. So you can use the k method, or in this case, what I'm going to do is I'm going to go straight into the factorization. Okay, so open up 2 brackets equals 0. So just think of this as like 2x squared minus x. All right, so if I write that underneath here, it'll make it a little bit easier to factorize. Okay, so we get here 2x, but in this case it would be e to the x. And then over here you would get x, which is e to the x. Then our numbers over here is going to be plus 1 and then minus 1, just to factorize it, okay? So at this point over here, we get e to the x is equal to minus a half, or e to the x is equal to 1. All right. So guys, what you can maybe do if you don't feel comfortable with this is go and try the k method. All right, you'll get exactly the same answers. Now, if we have a look here, this is a positive number. Okay, this is a negative. We cannot get a positive equal to a negative. It's not going to happen, so this is no solution. Okay, so in other words, e to the x cannot be equal to negative a half. The only one that we can get a solution is with this one. So I'm going to reverse the exponential into a ln, and we get that x is equal to ln 1. Now this is one of your definitions. Ln 1 is equal to 0. But you can even do it on the calculator if you just want to double check yourself. So ln 1 is 0. All right. Let's have a look at question 4. So we've got ln x equals 5. With this one, I am going to reverse the log. And remember, we can swap between these two things. Okay. So what is our base here? Our base is e. So we get here x is equal to e to the 5 just by reversing this. And then on your calculators, your E button is over there. So shift E to the power of 5. And rounding that off to 2 decimal places, we get 148,41. All right. Let's have a look at example 5. We've got ln e to the 2x minus 5 over 4 equals x. Okay, so with this one over here, what I'm going to do is I'm going to get rid of the ln form and put it into exponential. So basically it's in this form here, okay? And I'm going to reverse that form by putting it back into that one, all right? So what is our base? It is e. So we get e to the power of x is equal to this thing over here, which is e to the 2x minus 5 all over 4, all right? Just multiply up by the 4, and we get 4e to the x is equal to e to the 2x minus 5. Take the 4e to the x to this side, and we get e to the 2x minus 4e to the x minus 5. Okay, so what I'm going to do here, grade 11s, is I'm just going to use the trinomial way because it's just a little bit quicker to factorize. So just think of this as x squared minus 4x minus 5. How would you factorize that? X 5, 1 minus plus. Okay, so we get here e to the x, because that's what that was, minus 5, e to the x plus 1. Okay, so that means we get e to the x is equal to 5, or e to the x is equal to minus 1. So this is very similar to that previous example where we have a positive number equals a negative. We cannot have that, so that's no solution. The only one we can have is this. So here we'll get x is equal to ln 5. You can put that on the calculator, ln 5, and we get x is equal to 1,61 to 2 decimal places. All right, example 6. We've got ln 2x squared plus x minus 3 equals ln 2x. Now, grade 11s, because we have a ln on both sides, what we can do basically is we can drop the lns, okay? I don't want you thinking of it as dividing through by ln, because we can't do that. What I want you to do is just to drop the lns. So basically, we've got ln of something equals ln of something. So essentially what that means is it means that, well, that something must be equal to that something because we have an equation, all right? So what we get here is we get that 2x squared plus x minus 3 must be equal to 2x, okay? And now what I can do, just take the 2x to the other side, becomes a minus, so we get minus x minus 3 equals 0. Trinomial to factorize, and we get 2x minus 3 and x plus 1. Can solve for x, so x is equal to 3 over 2, or x is equal to minus 1. All right, and there's your solutions. Right, let's have a look at example 7. We've got mod ln x minus 3 equals 2. Now remember, with your absolute value, the definition of absolute value, it is equal to two things. It's either equal to x or minus x, depending on if x is positive or x is negative. All right, so that's what I'm going to do here, is I'm going to split this up. We can either get ln x minus 3 is equal to 2, which is your positive arm, or you could get ln x minus 3 is equal to negative 2 for the negative arm, okay? What I'm going to do here is I'm just going to reverse the log, or in this case, the ln, and get it into exponential form. So it's base e. So we get e to the power of 2 is equal to x minus 3. So that means that x is equal to e squared plus 3. And I can work that out to 2 decimals. So we get e squared plus 3. And to 2 decimals, we get x is equal to 10,39. In this case over here, we'll get e to the minus 2 is equal to x minus 3. So that means that x is equal to e to the minus 2 plus 3. So I'm just going to change that to a minus 2. And we get x is equal to 3,14. All right. Last example, grade 11s, which is example 8. And we have ln x minus 2 plus ln x plus 1 is equal to ln x plus 6. So what I'm going to do here is I'm going to use our log laws. Now remember, log and ln, the laws work the same. So if your bases are the same and you've got your log, or in this case your ln, and you're adding, what do you do with these things? You multiply them. And that is what I'm going to do. So it's ln x minus 2 multiplied by x plus 1 base e equals ln x plus 6. Okay, just like with the previous one, I've got the lns on both sides. So that means, because we have an equation, that this thing must be equal to this thing. All right, so I'm just going to drop the lns. So we get x minus 2, x plus 1, must be equal to x plus 6. Okay, let's FOIL this out. And we get x squared minus x minus 2 minus x minus 6 equals to 0. X squared minus 2x minus 8 equals to 0. We can factorize this, and we get x, 4 and 2, minus plus. So we get x is equal to 4 or x is equal to minus 2. Now, we must just be very careful with what answers we get here. The reason why is because we have these variables in this position over here. So, if you go back to the definition of your logs and your lns, what we can't do, there's certain things that we can't take the log or ln of. So let me just show you, for example, ln of 0 gives you a maths error. We can't take the ln of 0. Let's just have a look at ln or log of a negative number. Again, maths error. So whatever's inside these brackets here has to be positive. Okay, so what I'm going to do is I'm just going to interpret my answers here. So if I put 4 in here, I'm going to get 2, so that's good. I'm going to get 5 there, that's good. And here I'll get 10. So 4 satisfies each one of these. If I put minus 2 in here, I'm going to get negative 4. Now we can't do that. We can't take ln of a negative number. So immediately this one fails. So no solution. Okay. Right, grade 11s, what I would like you to do is your exercise just after that, which is this exercise here, and you can do all of those for me, please. Thank you.